Good morning. Today, with the series of complex analysis, our topic is complex integration. We are continuing with this topic, and now we will start important concept of Cauchy integral formula. This is very useful to find out the integration of a complex integration. So, the objective of this lecture to know about Cauchy integration formula and how to apply in complex integration. So friends, after this lecture we have a quiz on the basis of Cauchy integration formula. So let's move to our lecture. What is Cauchy integral formula? Cauchy what is Cauchy integral? Let fz be analytical function. Analytical function means fz satisfies the CR equation, Cauchy-Riemann equation, and secondly, it is differentiable in its closed region. Function in A simply connected domain G bounded by rectifiable plane curve P and is continuous on C, then for any point z0 of G, f z0 is equal to 1 upon 2 pi iota fz minus z0. We have to prove this. Now prove. Let gz, we assume this function is gz, fz upon z minus. Okay, we assume that the function which is required to uh, integrate this is gz. Here at z is equal to z. It is its function h not analytic because at z is equal to z0 only this point the function become not defined. Okay, so at z is equal to z0 this function is not analytical because exist ही नहीं करेगा, then it is not analytical. So So we can say gz dz is equal to gz or actually we make a curve inside a circle. Okay, this value here is z0. So fz z minus z0 for this function we gave the curve name is c1. C is equal to c1 because both are defined on z0. Now we can see we can do fz minus fz0 plus fz0. At a point of z0, the function value is fz0, z minus z0. Now we can do fz z minus z0 dz plus here z0 z minus this is on c1. c1 this is fz0. We segregate the term, separate the term. Have we taken fz0 here? Actually, we add and subtract fz0 with the function value at z0 and we separate the terms here. Even the name is I1, I1 and I2. Now we can do taking I1 and I2, the name of the integration. So it can be easily to find out I1 value separately and I2 value separately and put in this equation. In I1, put this is a circle equation, circle curve is circle, so z minus z0 will take r e to power alpha. And z is converting z0 plus r e to power alpha. So implied dz is equal to iota e to power iota theta. So we put the value f z0 z minus z0 dz is equal to f z0 0 upon 2 pi r iota e to power iota theta r e to power iota theta 2 pi iota. This will become 2 pi iota. No. Actually, we put the value f z0 taken out. It will z minus z0 is become r e to power iota theta and dz is done iota e to power iota theta. Z. Here r is also. So we put the value and integrate. Integrate this R to R cancel. E to power iota theta to e to power iota theta and convert in iota d theta. And integration of d theta become theta 0 to 2 pi. Then put the limit. We get 2 pi iota and then okay. Now so we can say so we can get f z z minus z0 dz is equal to 2 pi iota f. This is our value of. Now we put the value in I1 in this. So we get f z z minus z0 dz is equal to 2 pi iota f z0 z minus z0 equation f z is continuous function. So fz minus fz0 epsilon wherever z minus z0 now fz minus fz0 z minus z0 dz is less than equal to fz minus fz0 z minus z0 dz is less than epsilon upon r. We taken this 1 upon r because this is less than so dz it become scale upon dz is equal to 2 pi r. Boundary of circle. So it is come 2 pi. Now we see fz minus fz0 z minus z0 dz integration the integration is less than 2 pi by this is equation 2 by equation 1 and 2 we find this value here is less than 2 pi epsilon. So epsilon we can take as 0. So we get by 1 and 2 fz upon z minus z0 dz minus 2 pi iota f z0 is equal to 0. So fz0 we take downside 1 upon 2 pi iota fz upon z minus z0. This is called the Cauchy formula. This is called Cauchy formula of integration. So here we see the again this is called Cauchy integration formula. Formula fz0 at a point z0 the function is not negative where the value of function is equal to the 1 upon 2 pi iota integration fz upon z minus z0 dz. Again I explain. Again, given that fz be an analytical function in a simply connected domain bounded by a rectified curve be in continuous. It's continuous. Fz is continuous. So the fz0 is equal to 1 upon 2 pi iota integration. So here we assume this value is dz. This function equal to dz. And we make another circle inside the given region. So this is also satisfied the same condition. So f0 we can write it for C1 and C1 we can do minus and plus we add and subtract fz0. So this will become fz0 this side and fz minus fz0 z minus z0 this side. Now for I1 we assume we take z minus z0 is equal to r iota theta because this is a circle so we can assume z is equal to z0 r e to power iota theta. Dz become iota e to power iota theta r. Now fz0 z minus z0 dz is equal to fz0 0 to 2 pi. Value put the value of this 0 to 2 pi for a circle. Z0 will be taken outside. Here is the dz value iota r e to power iota theta upon r. This cancel I to I. 3 iota theta to iota theta become only iota d theta. Integration of d theta is theta to 2 pi. This is the value of first part. I1. This is the value of I1. So this is I1 we get. Now we point I2. We come to the point I2. For this value, we given that the function is continuous. So continuous function. So fz minus fz0, the change is very small upside. We take upside and z minus z0 have less than delta. So z minus z0 is less than delta. Now we can divide both parts by z minus z0. So integration fz minus fz0 upon del upon z minus z0 dz, the modulus of this is less than always to inside model. It can be taken as epsilon upon r because this is continuous function. So we can take epsilon as very uh, small positive quantity. So we can take it less than epsilon upon r and will become dz. Now dz show the boundary of a circle with radius is r. So we can take it 2 pi. It converts less than 2 pi epsilon. Now now this is 2 pi epsilon. Now y 1 and 2. Integration fz 1 upon fz upon z minus z0 dz minus 2 pi iota fz0. So fz0 we take this side and 1 upon 2 pi iota. This is the Cauchy. This is Cauchy. Here we take epsilon tends to 0. So this term is tends to 0. This system tends to 0. So we get. Now we move to the another important theorem. Theorem is Fz is analytical in domain and C contains the circle C z minus z0 is equal to R. Then f z0 1 upon 2 pi 0 to 2 pi f z0 plus r e to power iota theta. This is also called Gauss mean value. The, it can be written as the value of fz at any point z0 equal the average of average of its value on the boundary of the circle. Gauss mean value theorem. What is saying that the value of fz at any point z0 equal the average of its value of boundary. बाउंड्री पे जो वैल्यू है z की उसके एवरेज की हो, दैट इज कॉल्ड गॉस मीन वैल्यू. The if fz is an article in domain G and G contains a circle, G contains a circle there, then fz0 is equal to 1 upon 2 pi this. Mean value theorem is saying that the value of the fz at any point z0 equal to the average of its value on the boundary of the circle. Circle के boundary. So there we discussed about circle. So we know at the circle it's given as z z is given curve or given circle. So here z is equal to z0 plus r e to the power iota theta. So dz is equal to convert dz is equal to r iota e to the power iota theta. Now by Cauchy formula, now by we use Cauchy formula because here given curve is circle, so we take that is equal to z0 plus r e to the power iota theta and dz is r iota e to the power iota theta. By Cauchy formula, fz0 is equal to 1 upon 2 pi iota f z z minus z0 here z only. Okay, this is our Cauchy integral formula. F z0 is equal to 1 upon 2 pi iota integration on closed curve f z z minus z0 dz. Now put the value f z0 1 upon 2 pi iota f z0 plus r e to the power iota theta 1 upon r e to the power iota theta dz is equal to r iota e to the power iota theta. For 1 upon 2 pi iota 1 upon 2 f z is equal to because z is equal to z r at theta from here and dz is equal to this. Okay. Now from here this is cancelled only. So f theta iota. So you can write iota is constant, so we take out and cancel 1 upon 2 pi f z0 plus r. This is r was mean value. This is called mean value. Again we will see that given that on a circle, so we take z minus z0 is equal to r and z is equal to z0 plus r e to the power iota theta. So dz is equal to r iota e to the power iota theta d theta. So fz0 by Cauchy formula. Today we have this and fz0 is equal to 1 upon 2 pi integration fz upon z minus z0 dz. So we put this value in Cauchy formula. So z, when you put z is equal to z0 plus r e to the power iota theta, so dz become r iota e to the power iota theta. So this is cancel and we get 1 upon 2 pi integration f z0 plus r e to the power iota theta. This is called outcome. If if fz is analytical, one important remark analytical in the region region bounded by two closed curves C1 and C2 and Z0 is any point in the region then fz0 1 upon 2 pi iota fz z minus z0 minus 1 upon 2 pi iota Fz dz upon z minus z0 c1 c2. If fz is analytical, the sentence is that if fz is analytical in the region bounded by two closed curves, if bounded by two closed curves, then and z0 is any point in the region. So fz0 at a point z0, the value of function is fz0 is equal to 1 upon 2 pi eta integration fz z minus z0 dz minus 1 upon 2 of I eta fz dz z minus z0. We have C2 is the outer curve. So this is also very good statement when the curve is bounded by two more closed curves. Now then we will move to the another theorem or other formula. Actually, there we have to derive some formula. If a function fz is analytical, a holomorphic with the in and on a simple closed function contour, then a derivative at any point z0 inside C is given by f dash z0 1 upon 2 pi eta fz dz z minus z का means if at a point z0 the derivative value the derivative of the derivative f dash z0 at the point of z0 the derivative value is equal to 1 upon 2 pi eta integration fz dz z minus z0 whole square. So students, in next lecture we will prove this theorem and the main by the conclusion of this and recurrence this theorem we get the Cauchy general formula, okay, which will be very important formula for solve our question and complex integration and find the derivative of the function at z0. So this is very important concept of complex analysis, and after this is also used for and after this we will read residue theorem singularity, then we will use this formula also. Now the time for the quiz. Move. What is the Cauchy theorem of integration for square? The curve is given square pi sin to z. So student, this question I have discussed already. This is a closed curve. A square is closed curve, and closed curve, the Cauchy theorem integration. Here Cauchy integration is 0. So this question I also put in yesterday video. You can see this video. Now, what is the z minus a modulus is equal to r over circle? What is the value of this? We know that z minus a is equal to r e to power iota theta. So the value here is asking z is equal to e to power iota a, z is equal to e to power iota theta, theta is equal to given here a plus a. So at the point b is equal to right answer. B is equal to z is equal to a plus e to power iota is the right answer. And complex function 1 upon z integration with the circle, it will be give us a circle is taken integration, a circle made when the integration is taken by 0 to 2 pi. So at 0 to pi, if we put the value that theta is changed 2 pi minus 0 to 2 pi iota. So the value of this complex integral 1 upon z integration is give us the result 2 pi iota. So the option is the right option, 2 pi iota. In z minus iota is equal to 2 is the equation of, it's showing the which curve? Circle with center origin. Actually this is the z minus iota. We can write x z as a x plus iota y. So and minus iota. When we take iota common, we get y minus 1. So x plus y minus 1 iota modulus is equal to 2. Then we remove the modulus, we get x square plus y minus 1 whole square is equal to 2 square. So the center become the, this is the circle which made on y axis, and the center of this 0 and 1. So the B option is the right, circle with center 0 1. It is a center with circle with center origin is wrong because it is circle but the center is 0 1. Parabola is not possible. If function is w1 upon z minus a is not aligned analytical. This is not analytical at z is equal to a, because at point z is equal to a, the function is not active, and this at this point the dw upon dz we get 1 upon z minus a whole square. So at the point a, this is not active, so this is not analytical. Thank you very much, students. I hope you clear the concept of Cauchy integration.